downside of noise in your data is that people want to have privacy in their data. If you're a customer in a database, if that database gets leaked or if it's somehow out online, you may not want to be identified as being that particular customer. For instance, there was, so who's heard of the Netflix challenge? So there's this contest put up by Netflix maybe 6 or 7 years ago where they put out a bunch of information about their customers, about what movies they had rented, how they rated them, and said, we want a better prediction algorithm, how to predict which movies to suggest to the customers. And they put out all this data, and the research community dove into it and really improved this and created a great new algorithm for Netflix, which worked a lot better than before, apparently. Created a lot of cool research. And they were going to come out and say, okay, this was great, we're going to give you even more data, and hopefully you can come up with an even better, even better algorithm. There was like a $1 million prize for the best group, which ended up grouping a bunch of groups together, so it was split pretty fun. But so they were about to do this, and then some researchers came and said, well, I can look at the data on IMDb, which has users who are public, have made themselves public. So all the data from Netflix was supposedly anonymized. And they can find people who rated movies similar and fairly accurately identify a lot of the users in the Netflix data. So, the users on IMDb had identified themselves, so this shouldn't have been a problem. But the thing was, people didn't always publicly rate all the movies they watched. Some people watched some movies which maybe they'd be embarrassed to say they liked. Maybe they liked, maybe it was a really manly guy who liked action movies, but he also liked these romantic comedies occasionally, and he didn't want the world to know that. Well, on Netflix, they had all that data. He thought it was private. So now someone can identify him on IMDb based on all the action movies he's watched, and then say, oh, you also like these romantic comedies, haha. So this is a mild case, though, right? There could be even worse cases with this data leaking. And so one way of dealing with this is to add noise into the data in a certain way so you cannot recover identities of people. And so we'll maybe kind of talk on, it's hard to cover this entire area, but I'll try and give some intuition of how this works and why this sort of things work. And again, this is a very new concept in privacy and in data police that really in the last 5 or 10 years has been developed. And so we'll kind of, and along the way in several areas we'll talk about the ethics of dealing with this data and with mining this data in different ways. What are the issues with doing things with some of the modeling choices that we have? But this is a very good example of where the ethics come in. So then the next structural topic will be on link analysis, and this is basically these large graphs where you think of an edge as a link between two of the nodes, and the nodes don't have to be customers; these could be web pages. And when you think of the web as a large graph, where if there's a link from one web page to another web page, that describes an edge. Okay? If you think of the internet as a large graph this way, then this is kind of a really important insight that led to the PageRank algorithm. So who's heard of the PageRank algorithm? Is this still common knowledge? Who has not heard of PageRank? Okay, so a few people. So this is kind of the main algorithm that caused Google to be a successful search engine. So we'll talk about what search engines were like before Google invented, before Brennan Page invented PageRank, and how it changed things afterwards. And this is built on this idea of modeling the internet as a graph, and then modeling a Markov chain on top of that graph, and then kind of adding on some extra twists, and this really revolutionized the way we understand the importance of different web pages. So, and then how they do this at scale is a general technique called MapReduce, which has was kind of invented for this and a couple other internal things for Google, and now has enormous applications in lots and lots of data processing. Most Fortune 500 companies are using some form of this MapReduce system. So, and this was initially built to help scale up PageRank, so we'll talk a little bit about this, about how this MapReduce works. This is not so much of a data analysis technique, but is really important for the scaling, so that's what we'll talk about. So then also within graphs, another important question is finding the community structure, which these are close to each other. These are important for when you're, say, advertising. You may want to target a particular group. You want to know who's in that group, trying to identify these groups, or who is an influential person in a graph. Which edges are most important for conveying information from one part of a graph to another. So we'll again build on these same sort of concepts to understand the community and the information structure within these large graphs. And again, even these questions were not even able to be asked 15 years ago because there was no way to have large data. There was no way to collect it. So these are all very new developments. All right, and so then we may talk a little bit about summaries. This will kind of make it mix in a few different parts, I think, because it's very related to the first couple lectures, and then it'll fit in through various parts of the course. And these are ways of kind of taking a subset of the data, and then what can you say about the full data from that subset? If it's a perfectly random subset, you can say a lot about the data. Sometimes it's hard to get a perfectly random subset, but there are techniques to do that. And there are other techniques which work better than a perfectly random subset. And so one of the places where these comes up is what's called what's called streaming data, which is where data is you have data so large it doesn't fit on your computer and it just keeps coming in. So you think you're like a router on a network. You want to calculate something about all the data passing through without storing all the data. You just get to look at it once and then it disappears again. So we'll talk a little bit about this. I taught an advanced seminar last semester where we talked a bit more about this. So and maybe a third of the class was in there, so I probably won't go in as depth in this topic in this particular semester. This is another interesting area. Okay, so to kind of look back at these themes, again, the goal, as I said before, is the intuition for data analytics. So we want to look at our data and try and map it to one of these kind of types of problems that we'll discuss, and be able to get intuition of what the modeling choices we make to get it into the form of a question we know how to solve, and how this affects things, both in the accuracy of the question we're trying to ask, and also in how efficiently we can actually do this. How will this scale as our data grows? How easy is this? Those sorts of questions. And then the key step here is the modeling from some arbitrary, probably messy, maybe noisy data to some abstract data type where we can do something with it. If you have the raw data, I don't know how many people have experienced working with kind of raw, messy data you get if you're, say, trying to collect it in a survey or in a company. This one of the new dimensions of the so-called big data is the variation of the data. It's very weird and messy, lots of different things you don't know what to deal with. You need to make some decisions on what part of the data and some form you can use. And so that's another really key thing that we'll try and kind of focus on throughout the class, that how to make these modeling choices. And then the other half of this is how to process it efficiently given those modeling choices, right? So we're balancing these second and third points here. The choice of the model and how efficiently can we deal with the model once we get there. So the general plan is I listed a bunch of topics. We'll spend roughly 2 or 3 weeks on each of them. With inside each area, the goal will be to give a general overview and some of the very classic techniques that anyone who's taken a course in data mining should know. We'll be focusing on the model efficiency trade-off, and I'm very excited by lots of new developments in this area, so I'll be telling you about some things I think are really exciting and are really making kind of on the cutting edge as well. I'll try and do this within each topic. So this is really kind of a broad group of students in this class. We have undergrads, we have graduate students, we have only about maybe 2/3 of the class is actually in computer science. We have people in many other departments in here. So I'm hoping that everyone will find some interesting topics in the class. So some of these may be the more advanced topics, which some of the computer science students may be able to grasp, and other times maybe only people with more of a math background will be able to grasp all of the details of those things, but hopefully you'll get a big picture of what are the kind of the basic ideas and what is the cutting edge at the same time. And so with each of these topics, we'll have a short homework assignment. So it'll usually have some analysis you have to do. Some of that will be doing some programming on some actual data. Some of it will be more kind of, you'll be given a question, you'll have to do some analysis without actual data. Right? So just taking data and grunging with the data is not all of data mining. You also need to know how to take the data and understand what it is. So we'll try and have both of these things. So this will account for half the grade. The other half the grade is going to be a large course project, and I'll talk about that in a minute once I finish off some of these slides. This will be, so a lot of the homeworks, I'll try and make the data a little nicer and easier to deal with. We'll do a little bit of pre-processing for it, so it's a little bit cleaner state. So you can really see how the algorithms work and how you modify them, what effect this has. But this is very different than how you would use data mining in practice. In order to do that, you're going to get data which is in horrible condition. And so all of you are going to have to go through that part of the class. And you're going to choose, but you'll get to choose your own data set, and these come in a variety of formats, but probably not the format that you want. And you'll have to take that data set and do something interesting. I want you to get practice working with real data and kind of taking one of the techniques in class and doing a much deeper exploration of it. And so that'll be the goal of the project. So the project you'll see in a little bit, or if you've seen the course webpage already, it's fairly structured. There are going to be 6 intermediate deadlines throughout the semester. So if you're used to these class projects where you try and do them all in the last week or the last night, that is not going to be possible because you're going to have a bunch of intermediate deadlines. This is a bit challenging to balance with your ongoing learning the stuff throughout the class. So if you're exploring a topic that we cover towards the end of the class, well, we'll get around this because it turns out actually using the techniques there are going to be only part of dealing with the problem. A lot of it is getting the data and getting the data into the right form. And so the intermediate deadlines will help you build up to that. And then at the end, we'll do some form of presentation. So the class is basically doubled since the last time I taught it. So last time we had this big poster session, which was the last 2 times, which was very exciting. I'll have to try and assess and decide over the next few weeks whether I think that'll still be feasible or if there's something else we can do. But I think that scales pretty well, and that way you get to see all sorts of other cool stuff and other data challenges other people are getting into while also doing a presentation. Okay, so let me say a bit more about the homeworks. We'll kind of manage the class through Canvas. I don't have it up yet, but it'll be up by the end of the week. So there's not going to be a restriction to a specific programming language. So some parts are going to, especially when you're dealing with some of the matrixy parts, we'll design them so they're easy to do specifically in MATLAB. But if you are more familiar with another programming language that can deal with that stuff, that's also fun. Other parts are going to be harder to do in something like MATLAB or something like R. You're going to be much better off using something like Python or C++ or Java, where you can build some very simple data structures or use some built-in data structures. I think you will not be able to use a Daemine package the way we've designed things, but you'll have to actually see how the data is moving. And so, if you're a little unfamiliar with programming, as a few of you are, you may need to work a lot harder in this part of the class. But that's, if you want to really understand how things work, I think this is really important. And maybe if you are a computer science student, you may be used to programming assignments where you're given a very specific assignment. You're said, here's the exact thing you need to build, here's part of the code, you need to fill out this code, you need to build something with these specifications. These assignments, you'll be given some data often, but they'll be much more abstract. They're intentionally not kind of giving you things initially to work with, because when you're in the real world, that's not how it is, right? So they're going to be intentionally not too specific on what to do. And this causes some difficulties. Hopefully you can talk a bit amongst yourself and ask the TAs and me for some specifications when you're confused about something, but in the past, most people have been able to interpret them fine. Some people get caught up on this, but this is a warning ahead of time. And I'll try and give some bonus questions on the homework. There are lots of different skill sets. I'll try and add some challenging questions which aren't required to be answered, but you can get some bonus points towards the class. Hopefully maybe more fun if some other things are not as challenging. But those won't be required. Okay, so just mention a couple of things. If you're interested in kind of the more research side of what some of the faculty and grad students are doing, we have a group meeting Thursdays at 12:15 to 1:30. You're welcome to come. If you're a graduate student, you're looking for an extra 1 credit class. This may be a good thing to do. Some of it will be visiting people, coming and giving talks. Some of it will be students practicing research presentations. But if you do it for 1 credit, you need to give one presentation. Enough people sign up, then your presentation will be half of the time period or a third of the time period, just so we can fit everything. So there's a web page that'll schedule, or there's actually a better schedule on that web page. And this Thursday we have a visitor from Indiana University, and so you're welcome to come. So these topics, it's too bad if this had come at the end of the semester. This really builds on several of the techniques that we'll talk about in class, and is a recent kind of extension. So what this is really saying is they're looking at a robust way of doing regression in high dimensions in a subspace embedding way, which means that it can scale to really, really massive data. And so this is he's going to talk about a recent paper. Okay. All right. So what's next? I wanted to go over the class webpage. All right. So please, one thing I should have said before, please stop and ask questions. I know this is now a fairly large room. I'm very happy to take questions, but I'd almost rather just answer questions than actually cover the material. I think you can get much more knowledge by ways of interacting. I'll try and find ways of building that into a larger class if there's not enough question and answer. I'll also be giving a lot of the lectures actually on the whiteboard. I think it's better to actually see the material develop on the board And so we'll be doing that. So some of the things are going to be easier to show a lot of information on slides, and we'll use slides when needed. But a lot of things I'll develop, and we'll try and interact a bit more on the whiteboard. So we'll see how that goes. Okay, so if you haven't found the webpage, it's here. If you search for my name in Google, I'm usually pretty high up, and then it's linked off my webpage. Well, you know, it's hard to know, right? So if I search for my own webpage, they have a profile for me. They know I'm usually looking for myself or whatever. Sometimes I'm too lazy to type in my webpage or something, right? So or I'm just, I mean, most people have searched for themselves in Google just to see what's there, right? So if you can't remember this URL, you can find it off my webpage. Let's see. So this is. There we go. So Reza is one of the TAs, and there'll be another one. We'll announce office hours soon. We'll try and have them so they're aligned well with when the homework assignments are usually, and project assignments are usually due. So the TAs will be much more responsible for a lot of the questions on the homeworks, and I'll try and manage a lot of the questions dealing with the project. So most of the questions on the homework will be better addressed towards the TAs, and I'll be better address the questions regarding the project. And we'll try and schedule the office hours that way. Okay, so there are not really not really specifically any books for the class, although I do link to two books which are freely available online. This one I think you can buy a hard copy if you want to, and I'll try and link to the relevant chapters in that part of the class. This first one, this is the page for it. It's a bit more on it's a bit more on the database side of things than on the data mining, data analysis side of things. So it's not always the best resource for the way we'll be looking at the perspective of the class, but is otherwise a very nice and easy book to read. Sometimes it doesn't have the formalisms of the data as in much detail as I will try and go through it. They're, just their perspective is something different. The second book is not really a book, it's a collection of lecture notes in a really large PDF. And it's meant to be kind of a lot of the formalisms and mathematics that has to do with this new sort of data. I've heard some people say that, in computer science, the important mathematics behind it for the first 40 years, and this is, was automata theory. And this hasn't gone away entirely. It's still very influential, but this helped develop things like, in computer science, one of the big things was like the P versus NP question has helped develop this and the theory around it. But now a lot of the computer science is influenced by data, and this book covers kind of a new sort of mathematics that deals with the sort of data problems that we'll be talking about in this class. Okay, so these are kind of more formal books, but I actually have my own lecture notes which I maintain, and I wrote them up mainly last year, and I'll try and refine them and fix typos and stuff throughout this semester and maybe update them a bit. And these can be found linked under this column of the web page. So there's a schedule here, and the one for topic, this will have, so this one just has the slides for the class. But the other ones will have links to, to these notes that I put together, which are written up in PDFs online. And so they're pretty detailed notes going through some of the formalisms and trying to discuss some of the intuition. So I don't think you really need the book for this class. A lot of information will be in here, but these have not been as carefully checked for typos as, say, one other textbooks might be. So if you find typos, let me know. I'll try and keep updating them and refining them throughout the semester. Some of them have been up. I'll kind of link to new ones as we go. Some of them will link to the version from last year. So this link will either link to one of the two books. This MMDS book was the first one, and the CSTIA one is the second book, and I'll try and say which chapter is relevant to this part of the class when there's a good thing. So sometimes neither of the books covers the topic very good, and in that case I'll try and link to some other external links. The assignments will all have their due date in this column here, and the due dates will be fixed when the assignments are posted. I have rough positions of these so far, and it's similar with the project. I'm going to highly encourage you do your homeworks in LaTeX. And if you link right here, this goes to a directory with some example files for LaTeX. If you haven't used LaTeX before, there's a little bit of a learning curve, but a lot of other people in the class know how to do it, and there are fantastic resources on it. There's actually a wiki page just for LaTeX, where people ask questions, or there's a Stack Overflow thing just for LaTeX. It's a very powerful tool for producing nice answers, and so, especially if you're doing mathematics and what you're writing up. And so if the TA is unable to read your homework assignment because you didn't use LaTeX to format it correctly, then they have my permission to mark that. Okay, so if you're able to format it and write it up clearly in another way, that's going to be fine. But I'm going to encourage you to use LaTeX. I think it's an important skill to use in writing up formally and things that have to deal with data analysis and things that are technical. A lot of the publishing companies actually use something like this now, especially if there's any sort of mathematics in the book. So let's see what else. And then the last thing is the project. It's going to have these various deadlines here. So if you go on here, there's actually there's a big PDF which is going to describe the project. I'll probably update certain sections as we get closer to certain deadlines, but you can see there are various steps here. It's going to be within groups of 2 or 3. I'll allow groups of 1 under special circumstances if you have a very good reason for that. So if you work in a slightly larger, I think groups of larger than 3, it's too hard to figure out who actually did what and to work together in these manageable things. But your work will go down if you work in a slightly larger group. You'll be able to accomplish a bit more. There are people with various different skill sets in this class, and this could be an opportunity to work with someone who has a different skill set than you and combine together those things. Or maybe you have similar background, you want to go really in depth in something you're interested in. Both of those are fun. But you should take a look at this PDF and start looking at the deadline, start thinking about project topics, start thinking about who your partners will be. A project proposal is due the first week of February. Okay, so you're going to have a few weeks to get this together and think about it, but I'll want a proposal project by then. It can change. Maybe I'll say this is not a good idea, and you can change it, but I need you to have some ideas and to think through it and say, this is what we're planning to do by this point. And then the 24th, you'll have to have collected your data and have a short report telling you what you've collected at this point. So this is only a few weeks afterwards. You already have to start getting your data. This will take much longer than you expected to. Okay, if you haven't done something before, this will take a lot longer than you expected to. So that's partially why the deadline is so early, because not everyone will actually get this done on time. I don't want you to run into the problems later on because you haven't gotten the data in a good format. If you already are working on a topic, you already have some set of data. I'm okay if you use this data and this project, but I want you to carve out something specifically for the class. And a lot of this is discussed in this PDF. So I suggest you go and read through this and get a sense. And then there'll be an intermediate report and a final report and then some sort of presentation at the last day class, maybe a poster presentation. Okay. What else? So the homework will typically be due. We may decide to do something a hand in through Canvas. I haven't decided yet. But the homework will typically be due at the start of class on the day it's due. I want to do this so you don't. If I had to do it at the end of class, then people either are working on it during class or don't come to class because they're working on the homework. If I had to do it at the start of class and turned in here, then you actually have to come here. I'd like people to come to class. I think it's good to have people here and interactions. I think you learn more if you're experiencing it and do that. And so one of the other things is that I've set up a discussion group on Google. Some of you have already applied to join this. This was very useful last year. People had questions on homework, or I can make an announcements. So I don't know. Some people may not have gotten the announcement I sent out on Sunday that class. There wasn't really class on Monday. That's the only way I really have to communicate with everyone in the class. And the email addresses aren't always set up to when you'll check. I will, in the future, I will only post things on this group. You can see it right on the webpage, even if you're not a member. But you need to be a member to post things, so we don't get weird spams. But I'll post things here. You can set it up to whatever sort of notification you want. If you want to email every time update comes, or if you want to email every new topic, you can set it up. So I think this is the most convenient way to do that. Okay. I'm still a bit flexible on the schedule. If there are certain topics that you don't see listed on here, that you said, I took Daymine because I really want to learn about this topic. Just let me know. There was a topic I added that, like last year, because some people wanted to know about it. I'm happy to add in some stuff, or maybe I'll say, oh, that'll really be covered within this topic, so you can look forward to it when it's going. So please take a look at the webpage and let me know if you have any questions. So great. So this is what I had planned for class. If you have any questions about the class or how it's going to run, let me know. Otherwise, we'll start with some of the material on Monday.